Okay, let us move ahead on inferential statistics today. Okay, today I'll cover some essential concepts that form the backbone of inferential statistics. Okay, by the end of this session, you will understand the what and why of inference statistics and what is population and sample and sampling distribution, central limit theorem, confidence interval and confidence level, and so on. Okay, so let's get started. The first thing first, what is inferential statistics? What is inferential? Why do we need to use inferential statistics? So as I said earlier, the very first session, there are two branches are there in statistics. One is the descriptive statistics, other one is the inferential statistics. Within the descriptive statistics itself, we have seen the central tendency, measures of central tendency, and we discussed about measures of dispersion. In statistics, there are two branches. One is the descriptive statistics, and the other one is inferential statistics. In descriptive itself, there are two branches. One is the central tendency, measures of central tendency, and the other branch is measures of spread. We discussed about the measures, the mean, median, mode, and the range, standard deviation, covariation, and so on. And now let us proceed with understanding what is inferential statistics. Why do we need to use the why inferential statistics came into picture? What is the advantage of inferential statistics? What is inferential statistics? It is a branch of statistics. It involves using the sample data to make inference or draw conclusion. One second, yes, there is problem here. Please remember that in the real world scenario, you will not get access to the entire population all the time. Most of the time, you will not have access to the population. Even if you have access to the population, it will take time. It is a time-consuming process to take the entire population and making inference about the population. It takes time. Collecting the data itself takes longer time. Even if the data is available, it's a time-consuming process. And most of the cases, right, you will not have access to the population data at all. That is when the inference statistics coming into picture. I don't have access to the population data. Is it possible for me to make an inference about the population? Yes, that is possible using inference statistics. It helps us to generalize our findings beyond the observed data and make prediction or test hypothesis. Okay, it make inference about a population based on a sample data. It's as simple as that. The goal of inference strategy is to use sample data to estimate, right? I'm going to rephrase my statement, okay? Estimate the unknown characteristics of a larger population. First of all, I don't know what is the average height of the students in a college. Let's say in a bigger college, like Satyabama College or very, other colleges, right? Ishwar Engineering College. You have 10,000 or, 50,000 students are there. Let's say even the case of final year students, if you want to find out the average height of a student or average age of the student, the final year student, it is difficult. You need to measure each and every student's height. It's time-taking process, and also they have different branches, right? You need to go to different locations. So it's a time-consuming process. Is there any way that I can, make a inference about the population with the sample data itself? Yes, that is where the inference strategy is coming to picture. Using the sample data, you can estimate the unknown characteristic of the larger population. In my example, in the 10,000 students are there in the final year. Let us assume that the BE computer science final year students 10,000. Let's assume that, okay, hypothetically, okay. So 10,000 students are there. Is it possible for me to find out the average height of the final year student. It is difficult, it's time consuming process. Is there any way, can I use my sample to make an inference about the population? Yes. Using the sample data, you can estimate the unknown characteristics of your population. Look here, this is what your population. All the students are there in a college. Okay, this is your college students. 10,000 students are there. And but you don't know what is their average height. Average height of final year students. You don't know what is the average height of the final year students. Okay, is it possible? Let's say you draw a sample and you run a survey with let's say 40 to 50 students, and you measure their height and you note down each and every person's, right? Your sample size is 50. So we always say we always use a notation called n, right? We always use a notation called n. N is the sample size. N is equal to 50 students. Because measuring the height of the 1,000 students are time-consuming process. Instead, what you do randomly, you are calling 50. You are measuring 50 final year students' height. Okay, this is your sample. I call sample mean. I call the sample mean as X bar. Population mean is mu. My population mean I don't know. Mu is population mean. X bar is your sample mean. Yes, you have 50 students height with you because you measured each and every student's height. Ashik, what is his height? And what is Jayashree's height? And what is Jay Prashant height? What is Jivanandam height? And what is Leela height, right? Like as you measured each and every student's height, the 50 students height, but you randomly selected 50 students from the final year students, and then you computed the average. Since you have the data, you can compute the average. With this sample mean, it is possible to estimate the population mean. So here I use the term estimate. You can estimate the population mean, right? Using the sample mean, you can estimate the population mean. So what do you mean by estimate? Estimation is something like, we are making estimation, right? It involves some kind of degree of uncertainty. It is not, exact, value. For example, the 50 students average height is 174 centimeter. This is for the sample, the random sample of 50 students, final year students height is 174 centimeters. So the average height for this sample, 170. With this, just because 50 students average height is 174 centimeter, can I conclude that my population, all the 10,000 final year students height is also on an average of 174 centimeter? Can I conclude that way? That is why we are using the term called estimate. There will be some kind of variation. Right? That we will discuss it little later. But this is the whole idea of using the inferential statistics. Using the inferential statistics, we are going to generalize our findings beyond the observed data and make predictions, or we can make an estimate of our unknown population. So why do I need to use inferential statistics? It allows us to work with smaller sample. Like I said, working with the entire population is meaningless. Okay, so if I want to find out the customer's purchase behavior, if I run if I call each and every person who lives in India, it doesn't make sense, right? People will laugh at us. So what we do is you take a sample, smaller sample, using which we are going to make an inference about the larger population. That is where the inference statistics plays an important role. But the question is, like I said earlier, the average height of the 50 students in my sample is 174 centimeter. With that, can I say, by closing my eyes, all the 10,000 final year students in my college, their average height is also same as my samples mean? No, right? there will be, variation. There will be so how are we going to define that variation? Right. So that is where this inferential statistics comes into picture, and we have something called central limit theorem, everything, which we are going to learn it little later. Okay, as I move further, your understanding will evolve. Hence, I would suggest you all to please focus here. Now the question is, what is the difference between descriptive statistics and inferential statistics? It's pretty simple, straightforward. Using the descriptive statistics, we can summarize and describe the data. It gives us the gist of what is, this 5-number summary. Somebody is asking you 5-number summary. What is the minimum sales? What is the maximum sales achieved by my sales team? What is the average sales achieved by my sales team? What is the upper quartile value? What is the lower quartile value? You can give 5-number summary, or maybe 6-number summary. You can give mean also, mean, median, mode. You can give all the things, right? That's all. Okay, you can tell the average sale is let's say the average sale is 70K. But can you conclude that the average sale, just because in a specific sales team, let's say you have 5 different sales teams are there. Each sales team, they have 50 salespeople are there. 5 into 50, 250 salespeople are there. Just because you take an average of one specific thing, can you generalize all the 5 sales team, all the 250 sales team, all the 250 salesperson put together on an average, they achieved 70 K? With descriptive statistics, you cannot do it. That is where the inference statistics is coming into picture. Using inferential statistics, you can make inferences about a population based on a sample data. Another thing which you need to keep in mind is the descriptive statistic can be used with any type of data, whereas inferential statistics you can use only with quantitative data. If you remember this much, that is more than sufficient. It's a very simple concept. And these are the terminologies you need to remember it. For example, I have a population. This is my population. And let's say you have different values are there. Different values are there in the population. What you are doing is you are taking a subset of the data. This is your sample 1. Sample 1. So for the sample, let's say you have taken 3 values. Let's assume that these 3 values are 3, 8, and 4. Instead of saying, 4, okay? 4. In this, sorry, let's say 5. You will take 5. Okay. In this case, what happens? What is the average? If you find out the average for this sample, how much you will get it? So 13 plus 3, 16. Right? 16 divided by 3. Okay. And what I will do is I'm going to put another number. Here I just put 5 here. 5, 5, 5. And here, let's 5, 5, 5. Right? Let's assume that all 4 5s are there. 20 divided by 4. Okay, you get how much? The mean is 5. This is called your X bar. The mean, the sample mean is called X bar. And the population mean is called as mu. Mu is the parameter. The mean, the sample mean is called as a statistic. The population mean is also called as a parameter. I'm going to now, I just go back to my previous discussion. So here, in this case, using this sample statistics, which is mean, sample mean. So we are going to estimate the population mean. We are going to estimate the population mean because you will not have access to the population data, first of all, in most of the cases. You are running a survey with a few people, and that is your sample. With that sample, you are, since you have the data, because you ran a survey with, let's say, 50 students in this case, you have the data with you. With that, you can find out the average. But the population, can you find out the average? Very difficult. Okay. So using the sample statistic, we are going to estimate the unknown population mean, which is nothing but mu. The statistic and parameter, you need to be familiar with these 2 terms. If you are going to be familiar with these 2 terms, nothing is there. Okay. The sample mean is called X bar and the sample standard deviation is called S, whereas the population standard is sigma. And if you square this one, that is what your variance. If you square the population standard deviation, that is called a variance. And the size, the sample size is again. Okay, so we use the term N to represent sample size, population size capital N, proportion small p and pi. This we'll discuss it later. Correlation R and P. Up to this, if you can understand, that is enough. If you remember it. So all these sample related measures, we can say mean, standard deviation, variance, and size. We use this notation. These are called your statistic, and these are called your parameter. Anything related to population, we call it a parameter. Anything related to sample, we call it statistic. These are the 4 different types of statistics. If you remember, that is more than sufficient. These are the 4 parameter, population parameter. If you remember, that is more than sufficient. Okay, I hope all of you can remember it, because it's very simple to remember. You have space in your brain. I hope you can remember it. Next, we will understand what is population and sample.